get started on today's video, if you love our video, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new Real Parts videos. This way, you never miss another one. Since electric motors often require large amounts of electricity during their accelerating to the nominal speed, a soft starter can be used to limit the surge of current, known as inrush current, and torque of the electric motors, resulting in a safer, smoother, and gradual startup. Soft starters will protect your electric motor from possible damage, and at the same time extend the lifespan of your electric motor and the whole system by declining the heating caused by frequent start-stops, reducing the mechanical stress on the motor, its shaft, and reducing the electrodynamic stresses on the power cables. Large inrush current also places a high demand on the electrical supply system, which results in extra cost. Soft starters are commonly used in industrial applications that have a high inertia load that requires a large inrush of current. One example of this is an air scrubber or dust collector. These will have large fans inside. In this application, it will take some time to get the fan moving, but once the fan is moving, the current and torque load on the motor is reduced. In the system, the fan will pull air into the filters where dust particles are collected. Then the clean air is pushed back to the factory. Water supply applications are another great use for soft starters. When using pumps in a process, you have to bring them up slowly. If not, you'll cause pressure surges in the water system that could lead to dangerous conditions. Conveyor systems that move heavy loads can be maximized by using a soft starter as well. The soft starter will be located inside the control panel and will be supplied with three-phase power on the top. Then on the bottom, the soft starter will supply three-phase power out to the motor. The soft starter can be controlled either by direct start-stop wiring or it can be controlled over Ethernet. Both control methods have their advantages and disadvantages. Direct start-stop signals would not require a PLC. They would be less expensive. Using Ethernet control, a PLC is required. This will allow there to be feedback, which will give adjustable control and monitoring capabilities. Now that we've talked about some applications and how the soft starter is wired into a system, let's dive into the internal workings of the soft starter. The main component of a soft starter is a triac, which is designed to limit the applied voltage to the motor. Triac consists of two back-to-back thyristors, or SCRs. When an internal pulse is applied to its gate, it allows current to flow, which then sends current out to our motor. The pulses are sent based on ramp time, so the current will be slowly applied to the motor. This will allow our motor to start slowly, reducing torque and inrush current. When the motor reaches full speed, the soft starter and DOL work the same. The difference is how they act while getting to full speed. When comparing the voltage between a DOL starter versus a soft starter, we can see that there is a direct inrush of voltage on the DOL, where the soft starter takes more time to get up to full voltage. The current is more regulated using a soft starter. With a DOL, there will be larger spikes in current as the motor starts. With a soft starter, the time the motor gets us to speed is slower and more controlled, while a DOL gets the motor up to speed almost instantly. This can have undesirable effects that we will talk about next. The torque applied to the motor as speed increases is greater when using a DOL, opposed to a gradual torque increase using a soft starter. Now that we know what a soft starter is and how it works, let's go back to our industrial applications and apply what we know on why a soft starter can prevent undesirable mechanical and electrical effects. When a DOL is used in these applications, there will be a sudden impact at startup on the load, along with a rapid acceleration, which causes excessive wear. Our air scrubber fan will be driven by a motor using belts and pulleys. Using a DOL can cause the belts to slip and wear. With our water supply example, the DOL will cause pressure surges on the water lines. This can cause excessive wear, which could lead to line breaks. And our last application is the conveyor system. DOLs will cause strain on the components that drive the conveyors, along with the couplings and bearings. These undesirable mechanical effects can lead to continuous maintenance, unscheduled shutdowns, and shorter component life. There are also electrical effects that we want to avoid by using a soft starter. The heavy current surges that a DOL can cause can burn out contacts and motors. In conclusion, when an industrial application has a high inertia load that will require a large inrush of current, a soft starter is an ideal option for controlling the system. Also, we talked about the wiring and control of the soft starter, as well as the internal components, and how triacs control voltage to the motor based on ramp time. We concluded with undesirable mechanical and electrical effects that can be prevented by using a soft starter. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realcars.com.
This one I can change. Head over to Spiral Spectra. Nah, just kidding.
Okay. Apa yang kau?
Dia mostly macam dia compare dengan DOL. DOL kan dia terus start high top kan. So Saturday dia more to like slowly go, makin gradually increase lah. So dia tak bagi macam tadi dia tunjuk water pump kan, dia tak bagi terus pressure. So dia start slow compare dengan
Correct. Macam DOL dengan soft starter ni, soft starter yang saya kata lah, dia punya grafik jalan ni lebih lambat. Untuk dia peak tu lambat. Dan dengan DOL ni terus peak 0.1 second peak terus.
Yo, say.
Copy paste. Tapi mana better DOL dengan soft starter? Dia
Soft starter
dia
Depends on application juga. Application, betul motor. Contoh kau nak pakai conveyor kan, takkan kau tekan sound memang pergi lah benda tu.
Depends on application lah.
So kalau conveyor kita nak start slow, lepas tu benda tu pun slow kita nak boleh control semua tu.
Macam itu conveyor kat airport sana, dia memang slow speed.
Dia memang slow. Kalau laju, rosak bag. Macam tu lah.
To protect motor lah.
Sini to protect motor and protect everything lah.
And longer the lifespan of the model.
So actually this one yang dia mention tentang SCR. This one lah SCR dia. Dia punya transistor firing. Yang ni yang akan control untuk dia bagi gradually start, gradually stop lah. This one lah, dia circuit dalam starter ni lah. Jom kita try dulu lah.
Alih kan? Tak tutup power.
Tutup power dulu.
Tak pacak ambil.
Nanti kena shock lah bos. Kenapa?
Baru sambut OD, tak boleh kena shot lah. Baru angin.
Baru 19.
Baru angin sikit.
Ada? Baru 19.
Baru laju kat degree 19.
Dulu study international.
Oi.
Look, 19 lah look.
Budak kontrak.
I already 19.
19.
Yesterday, 19 right?
Yeah, just 18 saja.
Yeah, look 18 right?
Looks 18. You go. Hey, stop.
Tekan button stop. The mention is loads lah 18. Not 18. Hey. Motor guna motor ni ah.
I think better pakai itu.
Oh, okay. Kita sini dulu ah. Okay ah, ya dah.
Okay.
Sebab kenapa ini mana tukar?
Sebab?
Kabel tak ada lubang.
Yes. Jaga ini. Shoot. Ya, buka dulu.
UV tak ada lah. That's why counterclockwise, clockwise only mah.
Oh, tentu ni.
Dia tak ada apa dia punya converter tak.
Tak ada yang kepala tu.
Tapi motor sama lah. Dia punya
Apa dia?
motor ni sama dengan motor tu lain.
Lain.
Tengok
Sebab
kalau
spek tak sama. Spek lain lah. So how would you have a plan to have it? Ada yang posisi kena shot habis kena shot habis ya.
biasa lah.
No, mana lagi bahaya? DC or DC? AC? AC. AC lebih bahaya.
AC bahaya. Current, high current dia.
Dia tarik. Kau benda tu melekat kalau kau pegang. DC dia faham betul. Betul lah.
DC lah, 5 volt lah. Kena shot lah. 5 volt kena shot.
Ha.
24 volt kena shot. AC.
Biasa lah.
Sebab AC you touch ground lah. You touch the AC current lah. Confirm you shot lah.
But kalau angkat kaki, tak touch ground tak?
Let's go mana? Tak touch ground.
Tak macam contoh macam ni lah.
You cuba dulu. Itu tak pasti. Ataupun you tanya chat GPT. Itu tak pasti. Should be know lah. You jangan ambil dua kabel AC lah. Shot lah. Ui. Buka. Mana buka? Okay, cukup. Buka ni.
Buka. Macam mana dia nyala? Sebab dia pakai external punya power supply yang lain.
External.
Dia bukan, kita tak pakai 3 phase nya. Dia ada 3 pin kat belakang. Dia pakai single phase nya untuk control dia. Untuk dia punya components.
Wih laju. Okay.
Okay.
Tu soft starter tu. Misal.
This one actually the soft starter lah. Sekejap tukar slide sekejap. Actually ada satu slide. Okay. So dalam ni adalah soft starter tu. And then kat sini lah untuk elemen-elemen dia. Like example dia zaman kat depan dia. Kalau kita tengok kat dalam ni ada 1, 6. Ada 6 ni apa? 6 elements yang kita boleh control. So the first one actually dia punya class setting lah untuk motor protection dia. Lepas tu second one ada rated current dia untuk motor tu. Kita rated current ni kita tengok dekat motor. Lepas tu kita kena setting yang ketiga ni current limit. Current limit dia kita kena setting lah. Ada cara kira dia. Lepas tu yang dekat sini 4, 5, 6 ni yang kita akan control dia untuk step up dia untuk ramp up dia. Lepas tu kita ada untuk starting voltage dia. Lepas tu dia ada stopping time, maksudnya ramp down dia lah. So maksudnya dekat start dia akan slowly naik, bila nak stop pun dia akan slowly stop lah. So yang ni semua the information yang kita perlu lah untuk setting dia punya limit current tu semua. Kalau kita tengok kat sini ada, okay, tak nampak di depan sikit ya. Ni juga untuk current, limiting current. Yang ni untuk dia punya apa, starting ramp up time. Lepas tu ramp up down, ramp down. Lepas tu this one untuk dia punya voltage
Starting.
ya, starting lah. So senang je kalau kita nak setting dia ni, kena ada tool yang betul lah. So basically tool yang betul adalah drill, bukan screwdriver Phillips. Sebab mata sini pun semua Phillips. So kita just boleh pusing tengok macam mana semua, kita play je. So yang ni kat bila dekat high rated current dengan high limit current limiting, current limited current limitation ni kita setting. Kita dah setting dulu ni, lepas tu baru kita boleh setting lah berapa banyak kita nak pakai, berapa masa kita nak pakai untuk start, lepas tu untuk stop, lepas tu yang starting voltage dia lah, berapa persen kita nak. Lepas tu
Aku yang rujak.
ni lah parameter dia yang kita kena setting. Ada dekat situ, dalam ni ada logo dia. Jadi